Hello, we are Team Electronics. My name is Lauro Aguilar, and our project is the custodial swarm. Cleaning is a high priority task that is very important, yet it is tedious and time consuming. The prices to hire a cleaning crew can increment rapidly depending on a few factors. Technology has advanced enough to be able to delegate these tasks to robots that can do this automated and continuously without stopping over long periods of time. The design requirements are as follows. They must be able to clean up to 100 square feet of floors, 65 square feet of walls, and 30 feet of tables or horizontal surfaces within 2 hours. They must be able to give alerts of wet or slippery floors. They must be able to recharge themselves without human interaction. The robots shall be designed in a modular manner to reduce repair and maintenance costs. They must be able to lift up to 50 pounds of trash and bulky items, and they must be able to navigate around humans without collisions. Our potential customers would be schools, hospitals, and large organizations that hire cleaning services. Anybody who is in need of fast, reliable, and low-cost services will be interested in our products. The indirect customers would be the members of the custodial and maintenance services who will be directly working with our products to reduce the workload of their workers. And another impacted individuals would be the companies that provide these services and that are looking to modernize their products. This is my wall cleaning robot. It has an arm that has the cleaning tools. It has a X and Y system that will move it up and down and left and right. And it has various sensors that will help to navigate. Besides the linear system, it will have a motor that will rotate the cleaning supplies to help it choose the correct cleaning tool that it will need, be it the solution for glass or wall or the polishing sponges for glass and wall. It also has a moving system on the bottom. This module here will make it move front and back, and this one will make it rotate left and right. This is my circuit. I use 3 servo motors, 5 DC motors, 1 ultrasonic sensor, 2 9-volt batteries, um, 2 controls for 3 controls for the motors, an LED, and 1 photoresistor, various resistors, and 1 Arduino board. This is my flowchart. It has the 3 different functions, and then each function follows its own path. I will explain it when I explain the code in the circuit. This is my code. Again, I will explain how it works in the next slide. You will set up the variables, the pins, and start the serial communications. It will go into the main loop. I will set up the servo motor, and it will ask the hub for directions. So I'll start it. So I'll tell it to move, and it will ask me for the moving codes, which is to tell it to move left, right, front, and back. So I'll tell it to move front, and this DC motor will start moving towards the front, and it will turn the servo motor towards the right. Now I'll tell it to move back, and we can see it got negative, so we can going to the back now. And I'll tell it to stop. and it will ask me what to do now, and I'll tell it to start cleaning. It will ask me for a wall height, which I'll put 2 in this case, just for an example. We can adjust the wall height. So it will start by identifying the surface of the wall, glass or regular wall, by shining the light, and the photoregister will receive the reflection, and will identify what kind of wall by analyzing the light intensity. Right now it says wall, but I changed it, and it will tell us that it's glass. Now it's glass. So it uses a spray. It turns to use the polishing sponge, and it will repeat this in the until the x and y axis complete their predetermined numbers. And I'll show you the now it's asking me. I'll make it move again, and I'll show you the safety feature that avoids obstacles. So now it's going to start moving to the front, and I'll tell it that there's an obstacle in the front, and when I tell it to move again, it catches that there is an obstacle, and it will stop. And that's how it works. Thank you.
Hi, my name is Tristan Hogue, and this is my design for a floor cleaning robot for our swarm. The physical model is a 12-inch diameter circular framed robot powered by 8 motors, one for each wheel for omnidirectional traversal of its environment, one for the sweeping comb, one for vacuum suction, and one for a mopping brush, and one for cleanser spray jets. This model contains a front-mounted push bumper for retrieving small debris and has 3 ultrasonic sensors for analyzing its distance to objects and determining its own motion. It also contains an LED level battery level indicator on the top that's an array of 4 LEDs. In the electronic simulation, I designed 2 versions, one with radio communications and one with a wired serial connection, because Tinkercad doesn't support the full Python suite for UART protocols on microbit. To display this functionality, I have connected the microbits to 2 bidirectional logic level converters to allow the 5-volt Arduino to communicate with 3-volt microbit using 2 pull-up resistors with an N-type BJT to convert between the logic levels on its inputs and outputs for receive and transmit. I have also shown that my 8 motors are connected through H-bridge motor controllers, and the 3 ultrasonic sensors, and an array of the 4 LEDs connected to our 9-volt power supply. The code begins with a check for serial commands in the primary loop and begins operating through various functions to complete tasks. As you can see, I have quite a few functions here, all the way to the bottom. A lot of code went into this. But after it has received the start command, it will engage its cleaning motors and begin checking for its own distance and position relative to other objects in the room, and it is going to continue to check if it is stuck. And if it's stuck, it's going to flag the operators, and it is going to turn off its motors and kind of sit and wait until it is fixed. So I'm going to go ahead and engage the simulation and kind of demonstrate those 2 items. So in the serial monitor, you see I have it set to flag that it has received the command, and now you can see that the motors have turned on. And there's going to be a brief delay while it runs through its operations of checking its motion, and it's going to realize, because I haven't been simulating motion along the sides here, it's going to realize that, oh, I'm not moving. So I'm just going to sit here and turn off my motors, and then they just switched off. Now, had I been able to simulate the motion, it would have kept going, and had I put the distance under 5 inches, it would have determined that that was an object, and it would have tried to push it. If it couldn't push, it would have flagged the trash bot to come assist it in moving objects that are too large for it. This is my logic design for the entire process, the entire code. It covers all of the scenarios that I've programmed in, and with all of the various loops, where they start and where they terminate, and where they return back into the system. Up next is my simulation for the central hub. This is the logic design for how it communicates with the entire swarm. As you can see, based off of the labels in here, the device simply acts as a relay between the human operators and the swarm's individual robots. It tells them when to start cleaning, it receives data from them, and it reports commands between them, so that way the entire operation can run smoothly. Code for that is simulated in the same position, one Arduino up, and right now I have a simulated command just to tell our other Arduino when to start. Normally this would be programmed in to start at a certain time, or you have to push a button by a human operator. But after it runs that, and does this print, it's going to be continuing to check for its own commands. And it will have various cases. I use a switch case statement for it to receive certain flags, along with receiving integers and floats for various data types. And then it will perform those functions, such as it will periodically receive the time and position data of all of the robots so it knows where they're at and what they're doing at all times. And then if there is a flag for something that needs to be done that that robot cannot do themselves, it will transmit it to the appropriate robot and make sure that all of the cleaning items are done within the necessary time limit. My portion of the swarm, as well as the central hub, can be described as radio controlled, serially processed, and locally computed. Thank you.
Hi everyone, my name is Nawang Gurung, and today I'm presenting my dashboard as a part of Swarm Robot. So here is the CAD model of my dashboard. I have tried to make its design as simple as possible. So I make it a simple cube design with the 4 wheels, and I divided this cube into 2 parts. Behind the tube, it has a big trash container. All the trash is vacuumed through the front. It's underneath the robot, and on the front you can see the ultrasonic sensor that will measure the distance of object, and it will find any obstacle. So, and on the top there is a LED light and a buzzer that will indicate the status of a bird, and it uses Wi-Fi module to communicate with a hub and other robots. And for the dimension, I have tried to make as small as possible, so with a height of 10 inch and wide of 20 inch. And the next is the circuit board. So here in the circuit board, I've used a 9-volt battery. It will pass the power to the Arduino board, and Arduino board I use it as a microcontroller. And the next is the Arduino code of flowchart. So once it get the notification from the hub and other robot about the trash location, it will calculate the path toward the trash location. It will check if it has reached the location. If it has not reached the location, it will continue moving toward the location, and on the way if it will check whether if there is any obstacle. If it found any obstacle, it will stop there and reroute the path toward the target location, and it will continue until it reaches the target location. And once it reaches, it will check whether it has instruction to collect trash or return back to hub. So if at first there is a instruction to collect the trash, so it will collect the trash until all the trash is collected, and goes to decision. So it will check decision tab. Like once it collect all the trash, it will set the decision. It will set the target to the hub, and so it will return back to the hub and empty all the trash, and it will go back to the rest mode. Lastly, it will go back to the rest mode. So here is the circuit board of the trash board and the coding, Arduino coding. So in the top and bottom you can see the two motor. It's for the left and right wheel, and it has a sensor, distance sensor. There's one LED and buzzer and it is all powered by 9-volt battery. So let's see how it works. So right now there is no obstacle in the front, and once it get a command from the hub, all the motor will move forward, and as instruction from the hub, it will move back, left and right. And when it get obstacle is less than 11 inch, it will all the motor will stop, and LED light will turn on. Also the buzzer will make a noise to alert, and it will automatically find another path, and as per instruction from the hub, it will continue moving and avoid the obstacle. Okay, so yeah, the motor is controlled by H-bridge, and once it reaches the target location and collect all the trash, it will return back to the hub, and it will charge. It will empty the trash and charge the robot. So here is a entrepreneurial aspect. So the robot is very cost effective. All the costs are based on similar technologies. So for the floorboard, electromechanical system will cost around $800. Structural cost is around $900, and its annual maintenance is only $300. For the wallboard, electromechanical system is $1,000. The structural cost is around $1,000, and annual maintenance is $500. For the table board, electromechanical system costs around $1,000. Structural cost is around $1,500, and annual maintenance is only $300. And lastly, the trash board. The electromechanical system is around $800. Structural cost is around $1,000, and annual maintenance is $500. So why the customers should get this Swarm robot? The main reason is it clean 1,000 square feet of floor, 65 square feet of wall, and 30 square feet of tables within 2 hours. That is equivalent to 10 people's job. And another is it is all automatic. It gives a lot of wet and slippery floors. It charges itself without any human interference, and it navigates around without collision. And it is a low cost to repair and maintenance than having a human. And it can lift up to 50 pounds of trash in once, and it can empty the trash container without human interference. So these are the main reason it is very affordable, and the customers should get it. So yeah, that's it. Yeah, thank you.
Hello, everyone. My name is Wade Sessoms, and this is the TableBot as a part of the Robot Swarm provided by Group 14. Let's get started. This is the CAD model for the TableBot. It contains 13 parts, 4 wheels, 2 LED sensors, as you can see as the red and the green circles right here. 1 communications box is the purple box on the base of the robot. 1 distance sensor as well on the base of the robot. And 2 arms and 2 frame boxes, which is the frame of the robot, and 1 height pad at the top of the arm. For circuit design, the screenshot on the left depicts the robot traveling to the desired location, as you can see from these two motors moving. The motor on the left controls the front two wheels, as the motor on the right controls the back two wheels, so we want these running simultaneously together. The screenshot on the right depicts the TableBot actively cleaning a horizontal surface, as you can see from this motor. This controls the arm of the robot, which would clean off the horizontal surfaces. For our coding, this is what I have. I set up all my pins, set up my distance sensor with this right here, and then I gave some if-else conditions to allow the robot to go through its processes. This is the flowchart. This is the flowchart the TableBot will operate from. So the only communications path it has is through the central hub, which will tell the robot where to clean, and the TableBot will also notify the central hub once cleaning is completed. So this is the actual 3D CAD image we use for the TableBot. As you can see, 4 wheels, distance sensor, communications box, height pad, 2 arms, 2 frame boxes. On this side, you have your 2 LED sensors. Green would be going and red would be off. So to the circuit, this is the circuit, and we will start simulation. So if we are below 50 here, or in between 50 and 100, that's when our arm will start moving. That gives the robot knowledge that it's in position to start cleaning. If we still have a further distance to go, let's say 174 centimeters, we will move towards the robot or towards the cleaning area. And if we are too close to the cleaning area, let's say we come down in here to the underneath 50. Now we're going to move in reverse. That way we can position ourselves to get to the right destination. So let's say we're moving in reverse, we're going up. We're back up here to 60. Now our arm's going to start moving and start cleaning off the table. Once it's completed, we'll back up. And then we would take off again, go in the forward direction. And here are all the references we use throughout this project. And this is the end of the slideshow presentation. Thank you. Have a good day.